Alrighty, happy Tuesday again. We are here, week 11 of the semester. Oh my goodness, week 11. Um, Sorry for starting late. I was helping one of our other instructors deal with somebody who didn't want to follow the policy. So,
Yeah.
Miss Meta?
No,
Oh, the student? Okay, sure. Okay. So we're going to talk about exceptions, looking at proper ways for our classes to kind of further this idea of encapsulation. The idea that I've taken all of my details and I've bundled them up into one nice little package, and that I'm going to protect the integrity of my class. Make sure you never put me in a bad state. So what we looked at when we did planes, right? When we wrote our class, we'd return a true or false if something worked or if it didn't work. There's probably a better way to do this, and that's what we're going to look at with exceptions on how we can use them. Again, if you do continue on and you take object-oriented programming in Java, that's 2151, which, by the way, is not full yet, but slowly filling up for the winter semester, if you do want to take that one. We'll look at a deeper dive at exceptions, and you can do custom exceptions and sorts of things. So we're not going to do a whole lot out of Chapter 16, so there will be no quiz on Chapter 16 because we're just going to touch on some of the highlights. But this is an important concept when we talk about fundamentals of object-oriented programming, in that this is how my class communicates to another class that you did a bad thing, right? Rather than just return a true or false value that they might ignore, we can actually do this exception thing. And you probably remember we've done a little bit with exceptions where something might crash and we have to try that exception in a try block, or try the code that might crash in a try block and then catch the exception so that we don't crash. So it's a similar idea, but what we're going to look at is now the other side of that, where what do we do to cause an exception to happen to make someone else have to try and catch it? So with that idea of our airplane, and we said, hey, I want to change my altitude a bunch of negative feet, right? And if we were going to go below 0, we were going to say, no, don't do that. That's an option. And again, returning a true or false value is okay there, but a more forceful way to tell someone they gave us a bad argument is by throwing an exception, saying, hey, stop what you're doing now, handle this or crash because you did a really bad thing. So this idea that it gives us a better way to communicate because the person calling our code is forced to deal with it or crash, and no one wants to let their program crash, right? That's just it. You just look silly when your program crashes because we know we can handle these with try and catch blocks. So if we take a look at our, let's see, I think we got a class here in our file input and output example, right? Let's see if I can open that one up. Maybe it'll show up here. I should get chat on my phone, I'm sorry. Goodness. How do I go back? There we go. All right, this was the morning classes one. Ours was a different one, right? So we did file IO examples, I think is what we called ours for the evening. File IO examples. Right, and we had our talking stuffed animal example, right? Where we're going to save this to a file here. Now let's take a look at this one. So there's nothing really in here. How about we add a way to change this sound to make for fun? So this way we're dealing with the class we've already seen here. So if we wanted a way like, hey, this is one of the Build-A-Bear things, you can re-record that little message on the thing somehow. I think because you have to like push and hold it, or I forget what it happens to do, but there's a way to change it, right? So we'll say, okay, we're one of these. We can change the recording if we want to, which, by the way, if you record something creepy and then like slip it in someone's room without them noticing, like it's a fun way to scare people. Just some kind of like creepy clown noise, or I don't know, something silly. Not for children, but you can scare other adults with that. So we're going to make a set sound to make method here. And you know what? I don't even need to type it out, right? We can let the IDE do the work for us. So I'm going to insert code, and we're going to have a setter for sound to make. I'm going to say, okay, when you set a sound, I don't want to just take it though. I want to do some sort of checking here to make sure that you gave me a valid sound to make. because all I'm checking here is that it's a string. Now, if it's an empty string and you have no text, right? There's nothing in it. There's no sound to make. That's silly. You shouldn't do that. So what we can do is we can check that. We can say if the sound to make. And what do we want to do? Maybe equals, ignoring case, if it equals an empty string, right? Or we could check the length of it is 0, maybe. We've got lots of different ways here, but we'll say, hey, if it's empty, then what I want to do is I'm going to use the throw keyword. So throw is the keyword we use when dealing with exceptions to start one. So there's this idea of throwing and catching, right? So now instead of just being try and catch, now we're going to actively throw an exception here. So we're going to throw a new invalid, is it argument? Or no, it's argument invalid exception. So there's a ton. If you just look at like invalid here, there's so many built-in valid, so many built-in exceptions already in this Java library that are already ones you can use. Most of the time though, and then that's what you can look at is writing your own custom ones. It's like an argument, illegal argument exception. Here we go. So illegal argument exception is a pretty standard one here. And we can even give it a message here. So inside, because this is like a constructor for legal argument exception, we can give it a message like must have a sound. Or sound cannot be empty. How about that? Sound cannot be empty. Not be empty. So all we do is we say throw a new illegal argument exception. And if your code gets to a throw, it's similar to a return statement. It just stops executing. So we don't need an else here. We just, if this happens, this method stops running. Just done. We're not doing anything at all. If it doesn't happen, then we're free to go and set our sound to make. So what that means then, over in my examples, if I go make an animal, let's see, we've made a couple ones here. Oh, maybe we had an empty. Let's see, do we have an empty one? Because we're going to read it out of a file. Think about our file view or file IO example. So what was that? Just test.txt, I think we called it. So we still had a noise here, was ba. Right, so we were going to read one out. So let's see, and so let's add another one here, and let's see if it crashes on us. So let's add another animal. What animal should we call this one? Hey, Crow, thanks for joining us online. What should we call this animal, this stuffed animal? How about a clown? Our clown, what color? They're probably a red-faced clown or something, I don't know. And we just give it no noise here, so I'm just going to put another tilde, and sure, battery has power, we don't really care. But if it's empty here, we're going to see when this goes to run, excuse me, what we get out here from our parts. So let's take a look. I'm going to put a breakpoint in here. And using the debugger is huge. This is your best friend when learning to code, because we can stop, watch what's happening kind of midstream. It's fantastic. So we'll practice with this. A sheep? Okay, we'll do a sheep next, Crow. Maybe it's going to run. I was thinking about it. There it goes. Wow, it's going real slow. That's fun. I didn't even touch my cord here and the projector stopped. I have to wiggle it. There it goes. Are we running? Oh yeah, okay, I'm sorry. So it's waiting now. So it's waiting for me to enter the name of a file to read. So test.txt. Great, now we get to our breakpoint. So we're about to split. So the first line that was read is this line down here, fluffy, white, ba, true. So this one should be fine. When it gets split, now we have a parts array of strings, right? This parts array, and you can open that up in debugger, and you can see, hey, here's index 0, here's index 1, here's index 2, here's index 3. Sorry, it's relatively small. This one's hard to zoom here, but you can, when you're running it yourself, you can see it. So it's all well and good. So we'll keep on going. We make a new animal. Life is good. Now we see, is there another line to read? Yeah, there's another line to read. So when we read this line and we split it here, parts now is index 0 clown, index 1 red, index 2 empty string, index 3 true. Now our constructor is fine with this. Right? We never changed the constructor to use the set sound to make, so no exception happens. Again, this is another reason. If you have set methods that do some sort of checking, we should use them in the constructor. Otherwise, I have to repeat this logic and say, oh, hey, if you made me with an empty sound, you can't do that. Right, so we're going to call set sound to make, given the sound to make. Let me stop this and rerun it. So we saw I got empty, so when we hit that second constructor and we try and make our clown, it should crash on us because we didn't catch this exception. So the name of the file read, test.txt, and we get exception in thread main, illegal argument exception, and you see this is the message we gave. Sound cannot be empty. So this is forcing whoever's using our class to deal with this bad thing they did because we are maintaining the integrity of our object. You can't have a talking stuffed animal that doesn't talk, right? And that's our business rule. This is what we decided. If you try and give me an empty sound, we're going to say, nope, can't do that. That violates our rule. And again, for talking stuffed animal, maybe that's silly, but like our plane, hey, if you try and take my altitude below 0, instead of just returning a false, we can raise an exception. And they're forced to deal with it because you can just ignore a false message, right? No one is making whoever's calling my code check to see, oh, did I get a true or false result back out? But if there's an exception, you either crash or you catch it. So now what we could do on this side, where we're using that class, what's the other one here? Got too many of these open, I'm sorry. Goodness, where'd it go again? Here's our file IO examples. There we go. On this side, we could put it inside of a try block if we wanted to handle that. And if we don't have anything to do with it, we could just skip it, right? Say that was invalid. We could, on this side of it, because we know we're dealing with console input and output, we could then output a message to the console and say, hey, there's some bad data in the file, right? But my class has no idea that it's going to be used in a console-based application or a graphical user interface application or a mobile application or a web application, which, by the way, we teach all of those. I don't know if I mentioned that last week, right? We're going to do GUI, so we've done console and graphical user interfaces in 1500. You'll do more graphical in 2151. You'll do mobile applications in the Android class, and you'll do web applications in Java in the 2454 course, the PHP and JSP web development. So we cover all 4 of those. And that's sort of that idea that pipe dream, and pipe dream's a little bit unfair, perhaps, but if you write a class, it's totally portable, right? That's the goal of object-oriented programming. We write these nice little reusable modules. Like everything in the Java library, we can use in any one of those situations, any one of those user interaction pieces, right? The library doesn't care. So that's what we're trying to do, is we're trying to separate ourselves from how it's being used. Because that's the lovely thing, right? We'll make a class, and it's wonderful, fantastic. We're going to use it everywhere in all sorts of different places, and life is good, right? If you have the same library of class code for all of your business logic, you can write a mobile application for your staff. You can write a web application for your staff. You can write a desktop computer graphical user interface application for your staff. It can all use the same business logic classes to do the exact same thing. We're just giving different user interfaces is essentially what that does for us. So that allows us a little bit more reusability, portability of our code. So dealing or raising exceptions or throwing exceptions then is our way to communicate that, hey, you did a bad thing. And I'm a huge fan of invalid or illegal argument exceptions. There's all sorts of different ones we can do if we've bad things happen, but this is the most common one. This is the only one we need to look at for 1500. So this is the tool we use inside of class code to say, whoever asked to run this method here did a bad thing. Because we have no control over where our class is being used, right? The class code just exists, and we can use it 50 different ways if we wanted to, right? We could run a Build-A-Bear, we could run a little claw machine, we could run a web app, I don't know, any sort of silly thing. We could make a web store and sell these things online if we want to build a web application, who knows, right? But if you try and give me an empty sound, we should do something about that. Like, oh, hey, you forgot you could have recorded a message, and let them try again to give me a message or something. You know, in our example, reading out of the file, here's a, okay, well, now my file screwed up, I can go fix the file, I guess, but whatever option we want to do here. And then let me show you one more here. So if someone wanted a sheep, probably a gray sheep, because sheep are real dirty, right? Which is amazing. Like, this thinks gray with an E is misspelled. It likes gray with a Y or an A instead of an E. I always thought E was the preferred spelling for gray. Shows what I know about English. Sheep says meh, right? Or something. I'm sure that'll have a battery. So what we could do in our code here then, if we wanted to make a list of these objects out of our file here, I can make an array list. And remember, when we did array list, we mostly stuck with like strings and integers and things, but it had to be the capital class. It can't be a lowercase int here. It had to be the capital I integer wrapper class. But we can make it out of a talking stuffed animal if we wanted to. So we could have a list of talking stuffed animals, we'll call animals, equals a new array list of, again, you don't need the type the second time. It'll warn you about that. We'll add our import. And now this is much more flexible than an array because I don't need to know the number of animals in my file beforehand. Right? Again, array lists are almost always better than arrays because they are flexible. Life is just much easier with array lists typically. What I can do is I can make animals, and then we'll take my new animal and we'll add it to the animals list. Add my new animal. So when I'm done reading the file, I'll have all of the contents of that file saved to an array list that I can do then something with in memory. And I can say, okay, here's the ones you can win, or here's the ones that I sell. Here, I don't know, pick an animal to squeeze. We'll teach our little toddler what noise animals make. Do you ever have that like the little barnyard wheel? You'd like put a little crank on the side, it would spin the wheel and it would stop at an animal and it would play that animal noise. That is the most annoying toy in the world. I will go nuts if I keep hearing those animal noises. But my son loves it, so. Gray is British American with the AY? Huh. Alright, so we can add it to the animal list, and then we can put this inside of a try-catch block. We can say try. Here, we're going to try and do this thing because I know it might cause an exception. And then I'm going to catch an illegal argument exception. We'll call it EX. And really, I'm just going to print out a message. I don't know, like unable to read animal from file. I don't know, skipping. Sure, why not? And maybe we could give them a message like a line number perhaps might be good, but we're not tracking a line number right now. We could add a count. Let's add a counter. So int line number equals 1, I guess, right? And every time we read a line, then when we do next line, we'll take line number. Oh, I guess we'll have to do that after, right? Line number plus plus. Read animal from file at line. Add in our little substitution here. %D for digit, because sure, why not? Format that. Oh no, I'm sorry. So string.format. I think we did string.format. Given a formatted string, and then comma, I'll put in the line number. Line number. Right? Does that ring any bells doing string formats? Vaguely? It was a while ago, right? Okay, so we'll catch that exception. We'll say, hey, we were unable to do something about it. Well, okay, good luck. And then we got to keep on going. Now, it's giving us reds here because the myNewAnimal was declared inside the try block. Outside the try block, this doesn't exist. So we have to do this inside this try block, which is fine, right? If we were able to properly make an animal, then I can go and add it, right? If you declare the myNewAnimal outside, and then you start it off as null, and then you go assign it inside the block, we might end up with a null reference. Remember, like, so you can say, hey, I want a talking stuffed animal. We call it myNewAnimal. If all I do is this, the value of myNewAnimal is null. So if you don't assign it a value, so if you just declare it, its default value is null because it references an object in memory. And until we instantiate an object in memory, there is nothing in memory to point to. So where it looks in memory is null. Null means nothing. There is nothing here. I don't point anywhere. It's invalid. So it's better to do it inside the try block than have to deal with null. If you really wanted to, you could do it outside the try block with a check. Probably not preferred, but you could. So then we'd have to check in here. We'll say if myNewAnimal does not equal null, then I can go do this thing. Oh, it's even, oh yes, even warning, it's still warning us might not have been initialized. Okay, so explicitly set it to null, and then we can check. Again, this is awkward, but we can. So you want both ways? Is it easier to just leave this commented out, or is this fine to, I don't know, okay. So let's leave a note. Easier, just do this in the try block, where you know it's not null. Right? That makes sense? All right. So great. So now we'll have an animal list, and we can do something after we close the file with my list of animals, right? Whatever that happens to be. Right? So that was with a talking stuffed animal, and you can do this on any sort of checking if you want. If you have to have a name, we can do the same thing. Hey, if the name is nothing, let's say it's no good. The other thing you might want to do, this is technically, we refer to it as defensive coding. It's coding to make sure that explicitly we were given really good things because string is a reference type. Right? And we just said, hey, I might have a reference type that points to nothing that is null. When I make a talking stuffed animal, I can actually give it null here. And it's going to take name as null. And here on out, every time it tries to use name, it's going to crash. Right? In my code, when we try and use name, well, I guess we don't use name anywhere, do we? We'll just get null back out. So I don't think, okay, it's not going to make anything crash because we're not using it. But if sound to make is null, and you say, hey, does null equal ignore case nothing? It'll crash with a null reference exception. Because you can't say, does nothing equal blank? So a lot of times, it's even safer than we would say sound to make does not equal null and, or I'm sorry, if it does equal null or, there we go. If it equals null or it's empty, we could do this. And anytime you're given a reference type, you kind of want to check to make sure it's not null. Again, strings are the most basic reference types that we use, but you can make objects that have other objects as attributes here. So we could build another class here for fun. We build a new Java class here, and we'll call this a claw machine. And for fun, then our claw machine, then we'll have a private array list of type talking stuffed animals, and then a public claw machine constructor. Nope, claw machine constructor. Ladder import will assign animals, right, to be a new array list. This is instantiating it. Equals a new array list of type talking stuffed animal. Great. And then if we have a method like public add stuffed animal, given a talking stuffed animal, we'll just call it an animal, I can take my animals array list and I can add, oops, sorry, this is a void method here. I can add the animal to it. Now, I should check though, I mean add. Animals, oh my goodness. Animals, the array list one, add the animal. I should check first that animal does not, if it equals null, right? If it's null, then I want to throw a new illegal argument exception. Illegal argument exception. And we'll say animal cannot be null. Now, you can imagine this is going to be a little tedious. Every time you have a method that accepts something that's not an int or a float or a double or a char or a long or a short, any of those 8 primitive types, you really do want to check to make sure it's not null. Because our general behavior for dealing with objects is using them, right? And if it's null and I say animal.squeeze, right? And if it is null, it's going to crash. Or animal.anything will crash because it's null. So in defensive coding, we're going to make sure that anything we're given is not null. Okay, and I'm pretty sure, I probably should have checked this before. I thought there's a way to do this. It insert some code for that. But I guess not. I'm not seeing it. There's some shortcut for it somewhere. I forget, what is it here? Java NetBeans, we'll check shortcut. Shortcut, what is it? NetBeans shortcuts. Is it in here? Let's see. See if we find null. Does the page even load? No, okay, it doesn't have it here. I thought there was a shortcut. Maybe I'm thinking of a different editor here. But this sort of, hey, we're going to check to make sure it's not null. If it is, nope, no good, and let's keep on going. It must be C# I'm thinking of. We got some shortcuts there in Visual Studio. But this sort of thing is going to protect the integrity of our class Because if you say you're going to add an animal and you say, oh, ha, 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 it's not actually a real animal, I put nothing in there, and we go to use it, will crash and will look stupid, right? So the class is protecting its integrity. It's making sure you give it only something that it can use, that it wants. And it's different for every class, right? Now, sure, a lot of times it's just checking, hey, does the string have a value? That's all well and good. But for us, hey, we want to check the claw machine. We can also check, right, if our animal.battery has power. If not has power, this is kind of a terrible sounding method here, sorry. But we're going to say, hey, if it equals false. If you try and put an animal in my claw machine and the battery's dead, we could reject that too with an invalid exception. Hey, charge the battery first, dummy. If a kid pays me $1 to play the claw machine and they get out a toy that doesn't work, they're going to think the claw machine sucks, but you're the one that sucks because you added it. Right? So we have all sorts of different things we can check. Whatever makes sense to our class to make sure that it has its integrity and that we're using it the way it should be used. So we can throw exceptions. That's our big key here. Right? And then when we're using that class, you can either crash or you can try and catch it. Right? Just like we did with dealing with file input and output. Right? When we said, hey, I want to go read a file, that had to go in a try block because that might crash if the file doesn't exist. And again, we had a way around it. We could check, which is a nicer way to check here. But again, that defensive coding, that idea, we're going to just throw an exception if you do something dumb, right? Because we have no control over, once we write a class that's public, and we say, hey, anyone can use it, we don't have control over how it's used. And a lot of times as you work in larger organizations or on larger projects, it's not just you writing code, right? You'll do this part, they'll do that part, and at some point they talk to each other. And it's not that you don't trust the other person to do the right thing, but you want to make sure if they do the right thing, your part still works and doesn't crash, because then you'll look bad. Right? This idea, no, if you do the bad thing with my class, you are the one who's going to crash, not me. Right? We're putting off that responsibility on whoever's trying to use our claw machine to say, hey, don't put dead batteries in here. I almost said dead animals. That sounds awful in a claw machine. What a horrible claw machine game. Oh, I guess if they're taxidermied, right?
Yeah.
Oh, okay. Oh, all right. Taxidermied animals just like freak me out. I got all goosebumps now. It's just something about it. Some people do that with like their dogs. I don't think I could do that. I mean, yeah, if you love your dog, great, and you want to keep him around as a stuffed display piece, memory. I don't know. Okay. Get myself all freaked out. So that's dealing with exceptions, right? So we throw. Now, you'll notice we didn't need this try block here. Remember, like we were able to write our code without the try block, without the try catch, and it was fine with it. But when we tried to do a file here, it was not okay with that, right? When we tried to do a new file here. So if we just said, hey, I want a print writer, some file equals a new print writer, given some file.txt. Right now it's telling us, oh, print writer with a capital R, case sensitive, there we go. Now it tells us an unreported exception, file not found, must be caught or declared to be thrown. So there's two types of exceptions that can happen. One is a checked exception and one is an unchecked exception. If you're listed as a checked exception, the compiler will check it and not let you do the thing without dealing with it. And the unchecked exceptions just happen, and the compiler is not going to check for you. So you have checked versus unchecked. Again, you'll see more about that next semester, but that's why this stops us from doing it, and this one does not. Because that it's a different type of exception that you can use. And again, if you want to do custom ones, you can do them both ways. If you wanted a checked exception, we could do something other than illegal argument exception. There's other options. Sure, perfectly fine. Yeah, totally up to you. But that's why you'll see the difference there between it being in a try block, or sure, you're allowed to go for it, and if it crashes, it crashes. Okay, so we commit that to GitHub here. Make sure we got those examples out. Is that going to be okay? I just did all this in file IO examples. I didn't like start a new project for it. If you want to go back and look for it here. This is exceptions. I thought it'd be easier just to like modify an existing project, not product. I have no words today. All right. How do we feel about arrays and array lists? Feeling okay with them? They'll come up in our final project. Project 4 is more just about the file I/O stuff itself, because we're going to use the arrays and array lists in our final project that's coming up. We start talking about Java FX stuff. Exceptions is you should go over this. It's not required in 1500, but it seems real wrong to skip over exceptions and how you deal with exceptions and use them in proper object-oriented programming. So I always try and add this in. You'll cover the whole chapter in 2151 next semester if you continue on. I assume everyone does because that's the software engineering track. That's the one I know the most about, but other people in other programs take this course and they don't continue on. So just as a heads up, like this would be here.
Yeah, we in the game design one, it just goes from the stuff you to C++ one.
Okay. Yeah, you can. Yeah, C++ is a good one too. So, is that a question, sir?
Also, one thing, same thing. They C++. I think it's the same. Like I'm reading over and covering the same thing, but then you C++.
So it goes faster, and you'd go into deeper level. So it's a 200 level course. So generally, any course that's at like it starts with a 1 is considered a freshman level course, a 100 level course. The 200 level course or 2000 level courses are like sophomore level courses. Generally, it's not a hard and fast rule, and those are typically harder. They go deeper. So you'll see a lot of the same stuff, but you'll go farther in it. So when you deal with file I/O stuff, you'll do both types of files, text-based files and binary type files. You can do all sorts of fun stuff with that. And there's nothing graphical that I recall when I taught C++. I don't think that's a normal thing. So we take some time to do the graphics at the end to kind of introduce that. So the way it's laid out is a little bit funny. So data structures is generally the third programming course you'll take. The only required prereq is 1500. It's a lot easier if you've done 2 semesters of programming before that. Generally, the Java 2 is a better one, but if it's not required in your track, then sure, like a C++ and then a data structures is better. I've had students do it as their second programming course ever, and it's hard, and they do it, but it's hard going up front because there's a lot of concepts that you sort of take for granted that you got into that you don't necessarily have done before. That's definitely doable. Here's our catalog. Yeah, so definitely would recommend, oh no, that's the wrong one here. We want line services to look at what's next. Let's see what we had coming up. We're all CIS, right? Yeah, so 2252 is C++. So these ones are filling up. The online's basically full. There's one waitlist, but one open somehow. I thought they like put the waitlist person in there first, so that might not be available online. Dr. Ball is teaching it Monday night. If both of them fill, they'll open up a third one. We're watching it now to see if it's going to fill, but there's no, I don't know. We don't really have a lot of control over how often that one fills. The 2454?
Yeah.
So this one I teach. This one we do stuff in Java, but you don't need any of the stuff from the second Java course. So this is a nice one. It's all web technology. So half the course is PHP, and the second half of the course is Java, JSP, servlets. And you definitely don't need to be strong in Java. So that should be fine. We use some classes and things, but I try and go over some of that basics again. And it should have been done in 1500, but if it wasn't done strongly, again, we'll get into examples and stuff on it. That should be fine. Yeah, you'll be learning 2 different languages at once. It can be a little confusing sometimes, but they're similar-ish. I don't know. That PHP is different than some of our other languages. It's not strongly typed. So like in Java, you say, hey, I want something that is a string, I'm going to call it line. In PHP, you just say, hey, I'm going to call this thing line, and I can put anything I want there. It doesn't have to be a string. There's no checking on that. So it can get a little funky if you've only come from a strongly typed language. So it's similar to Python, where you don't have to declare the types. Yeah, PHP is a lot of fun. That's a good one. And definitely, I'm biased, of course, because I teach that one too. But yeah, data structures would definitely recommend to be later in the program. It's one of the harder courses we offer. It's a much more conceptual, looking deep into data storage and algorithm analysis, how fast things run, that sort of thing, what we can do to improve performance, that sort of thing. Yeah, but you can do it if you have to. It's doable, it's just hard. So. Yep. Cool. Yeah, next semester should be fun in the winter. We'll see. See how that goes. All right. Anything else you wanted to talk about for the last project? Right. We looked at deleting files here. We're looking at checking if files exist. Those are two things you'll need to like delete a product or to see if something's for sale or see if you can update a file. Right. You have to see if it exists first. To make a file with that name. Right. Remember, files, they don't have to have the .txt extension. It just makes it easier for you to open them in Windows if you want. So if they just give you a file name, you can check. We can see like, hey, if file name .contains .txt, then we're fine. So really, if it doesn't contain .txt, we can take my file name. I can say file name plus equals, oh my goodness, .txt. You're like, oh, hey, if you just say test and you don't put in the txt, I'm going to check it for you and I'm going to add it for you. So this sort of checking could be helpful. Because if they say, hey, I want to buy an apple, they're probably not going to say, I want to buy an apple.txt. And if you've saved all your files by .txt, you're not going to go find it. That file won't exist. So you just need to make sure you're matching. If you want to just totally skip the extensions, that's fine. If you want to add .txt extensions, that's cool too. Both are perfectly fine. Either option. But if you do go down that route, you can like check and make sure you're adding it here. So this way I should just be able to say test instead of test.txt. And it should work for me. Yep, and I get my test. Hey, look, unable to read it, and then I get the meh for my sheep. It worked. All right, so this was, we put them all in one file with this example, where with our project, we're going to have one file per item. That'll make life a little easier, because otherwise we have to load them all into an array list. And then we have to see, oh, where did they even go? Like over here, right? There we go. If we loaded them all into an array list of animals, then I could like loop through all of the animals and say, hey, is there an animal named Fluffy? Okay, sure, you could buy Fluffy for this much. So it's probably easier to go and have one item per file. And then when you update it, right, if they buy 10 of them and you have 20 for sale, you need to go rewrite that file to say, now the quantity is 10 after they purchase it, right? So even on the buying portion, we're still updating files because we're reducing the quantity. And if they say, hey, I want to buy 20 and you only have 10 for sale, you have to tell them they can't do that. We don't have 20 for sale. Come back later when we restock or something. Right? So we need to be checking, making sure as we're reading the data out, we know what the values are. We can tell them the price, give them the total price, and then you can ask for their Bitcoin address, wallet address, or something silly like that. Like, hey, where can I charge you money? And we should be in pretty good shape. I'm sorry, I'm still behind on getting these ones graded here. I'm going to get this. I still need to do the midterms too. Oh my goodness. I do, don't I? All right, I got to get the midterms and those graded. I'll get those in the end of this week for you. Sorry for the delay there. Got to finish wrapping those up. So aside from that, I think we're pretty good. We've got the rest of the time to work here on Project 4. We got this one to do next week, start a class. And then next week we pick up the final project that we'll work on up till the end of the semester. And we'll do our little games. You folks can pair up if you'd like to. You'll probably have a better experience if you do, even though it's a little bit funny to work with people sometimes. You'll probably get a much better result out at the end because you've had two people working on it, talking about it, figuring out the best way to approach problems and things. And again, there's no one right way to do something. That's the fun part of code, right? There's so many different ways you can solve the problem in code. So at some point, and when you take the data structures class, you'll learn like, hey, the fast way, and then you can actually look at it and say, okay, is this faster than this way? And there's some analysis you can do. It's not really a lot of math at all, don't worry. The math seems to scare people sometimes, but the math isn't bad to say, is this faster or not? So there's a better way, perhaps, but not generally a wrong way, as long as it gets the job done.
The website and then like all the sections like every time you be able to link like the ground with it, so not the ground, but like they do it for the website.
So the web system development is all about back-end web development. It's running a PHP website that's dynamic, talks to a database, can go look stuff up out of a database, like selling stuff, that sort of thing. It's not about making pretty sites. That's all the HTML5, JavaScript sort of thing.
You know, like making the website work.
Yeah, so we do the back-end side of things. So the previous Capstone project, but I think I'm going to change it, is we built a small little clone of Twitter, essentially. You could log in, you could post tweets, you could follow people, you could see their tweet, or I'm sorry, not Twitter, Bird app. And we built a Bird app, and you could go and see their bird songs or whatever. Probably not supposed to use copyrighted terms. But I had an issue. There's an example online, like a couple of people do this sort of thing for fun, like they post examples online, and they're actually really pretty, because like it's almost a full-featured clone, and I've had people turn that into me before. I'm like, when did you do all this asynchronous JavaScript stuff and CSS sort of thing? And they're like, last week? Like, no, you didn't. So that I'm tempted to change the project. I think it's a fun one though. Like it's not the hardest thing in the world to build like the base core piece of Twitter, like logging in, creating an account, posting stuff, following people, seeing results on a page. It's not the worst thing in the world to do. I started it back when Parler was a thing. So if that rings any bells for people, when they get kicked off of Amazon, I was like, what would it take if you wanted to write one from scratch and write your own Parler and like host it yourself? They're like, we kind of made fun of people in a nice way, right? Okay, I feel bad now. Sure. Anyway, yeah, that's the sort of thing we do in the web system development class, which is also weird because the 1200 course, Intro to Database Systems, is not a prereq, but we do everything connecting, talking to a database, getting data out of a database, updating data in a database. So I essentially do that course in 1 week, one of the weeks in the course, a real condensed version, and then I help people with all the database stuff. Again, another great one for group projects, because 1 out of 2 people has probably had it. Most of our students take 1200 at some point, but if you haven't yet, you don't need it. It just makes it make a little more sense is all. Cool. I think that's all I got for exceptions. We'll use exceptions in our final project. Again, so they will come back. This sort of idea that our class here will raise exceptions if we put it in a bad state. This is something we'll do moving forward from now. But it's not, hopefully not the most difficult concept, right? We're just checking, if you give me something bad, I force you to handle it or crash, rather than, hey, I'm just going to tell you return a value of false, because I don't know if you're actually going to do anything with it or not. So this is the more forceful way to protect the integrity of our class. Cool. So we got the rest of tonight. Sorry again for the late start, taking care of that other stuff. To work on the project, you can stay and work. I'll help you out on that. And we should be in pretty good shape. So we got 1 more week until Thanksgiving. Right, we'll do the JavaFX first week. So there's some more stuff to install. I have to show you how to install the right libraries. A couple other setup steps. Takes maybe half an hour the first time, and then every time after that, it's like a 5-minute thing to do. It's a little bit tedious, but it's not too bad. So I'll have that on how we can go through that. Hopefully before you leave that night, you'll have it up and running on your devices. Is kind of the goal. If you're using the virtual desktops, it mostly just works out of the box. You just have to do the 1 step instead of all the downloading steps. So we'll start that. We'll talk about the final project. We'll take a break. I'll come back and talk more about JavaFX stuff that next week. December 7th, totally your time. If you want to meet together with your partner, if you just want to come individually and work on it, I'll be here all night to help out anything we need to do. Ideally, you're done by the time you walk out this night. Is sort of the goal here, or like you have like 1 or 2 last little things to do, so you can focus on your finals for your other classes, and then on 12-14 you just come and play the game for us and say, hey, it does A, B, C, D, E, F, G on the rubric, and then you get your score and you walk out. That's the goal for the rest of the semester. We are almost done. Essentially 1 more week of content, maybe a week and a half if you count a little bit of extra stuff I want to show you, some other fun things, prettier things that aren't in the textbook, and then we're good. So it's been flying by, folks. It's been fun.
I'm just bored, to be honest, for like anything for
So the manage item mode should be in a loop. Like they can keep on managing items, adding, updating, or deleting until they're done, and then it just quits.
yeah.
For buying, that just it's only times they want to buy something over and over till they want to stop buying things. You don't need to be able to switch between the two. So like the first prompt, hey, manage mode or shop mode. Yep. And those could be different functions, different methods, right? Right. I'll have a manage mode method that does that loop, or I might have a shop mode method that does that, and that sort of approach. So yeah, using the item class, like we had our little stuffed animal class, you could if you wanted. There's not a whole lot of gain out of it other than like, hey, here's my getting my little separated string. If you want a one-liner, or because we're just doing one item per class, you can just say, hey, the first line will always be the quantity and the second line will always be the price. And you can just read 2 lines anytime you open a file because you know there'll always be 2 lines there. That's one option, right? The way we're doing like with a single line here and then trying to like loop through until it has next, you don't really need, you can say, hey, read 2 lines. Read the first line, turn it into an integer for quantity, read the second line, turn it into a double for the price. And then we're done. And then you can close the file because you know they'll all have 2. You don't need to have this other loop that says read everything until I've read it all because you know there's only 2. Awesome. Yeah. You guys talk a whole lot more than the morning class. I think everyone's really sleepy still at 10 in the morning. I get like no questions at all at 10 in the morning. It's weird. They used to be like a popular class that would fill first, and now like not very popular to come at 10 in the morning, which I get. I don't like 10 in the morning, but there's only like 7 people who want to take it next semester. So, but a bunch of you are stuck doing 10 in the morning for 2151 because that's when it was in the calendar. We might move this. I'm not sure. Don't really try and like have an evening option and a day option for a lot of the classes because not everyone likes night classes, and not everyone likes morning classes either. So some sort of option is good. Anyway, 10 people out of Auburn Hills, nice for their night class. It's good. All right, cool. Well, that's all I got for folks online. If you want to ping me on Discord, send me a message, email, we can go from there. We'll just be working on projects for the rest of the night.